Okay. Volume is cubic centimeters or milliliters usually, or liters are the base unit. Mass would be grams or kilograms or milligrams. Weight is sometimes in newtons, sometimes we use pounds. Depends on the situation. All right, so for today what we need to talk about is mass versus weight. And we've kind of introduced this already, and we talked about it at the beginning of class today, so we'll move through fairly quickly. So as we said, mass is basically how much stuff there is in that object. How much matter is in an object. And it doesn't change as an object's location changes. Its mass stays the same. And the units that we use for mass are grams. That's the base unit. Weight, however, is a little bit different. What we say is that weight is the force of gravity pulling on a certain mass. Right? We take an object's mass, we multiply it by the force of gravity in that location, we get the object's weight. So is the force of gravity a constant? Does anybody know what gravity actually is? Jonathan?
It's like a force where, like a big thing like Earth pulls, the like where it's other objects are attracted to it because it has a big mass.
Yeah. It's a force between any two objects in the universe have an attractive force between them. Okay? Whether they're large or small. Now, generally, we think of gravity in talking about planets and moons and so on, because gravity depends on the mass of the object. A very massive object will exert a great force of attraction to other objects. The force of gravity between those two objects is very large. Smaller objects still have that force, but it's very small. Okay? To figure out the weight of an object, you need to know two things about it. It's the object's mass, as well as the force of gravity at that location. Now, how does the force of gravity change? Like, where are some locations where gravity may be different than where it is right now in this room? Eli?
In space.
In space, obviously. That's probably the most common example. If you go to space, if you're in a location between the attractive pull of different planets or moons, then there may be almost no gravity. What else?
Maybe different parts of the atmosphere.
Certainly. Your location on the Earth also influences the force of gravity. Where is the force of gravity on Earth the greatest? Does anybody know that?
The core.
Yes, the closer you are to the center of the planet, the greater the force of gravity. So, for example, in a valley, a deep valley that's closer to the center of the Earth, the force of gravity is greater than it is at the top of the highest mountain, farther away from the Earth's core, the center of the Earth. When we calculate weight, often the metric unit we use is the Newton. Newton is a unit of force. Okay. 10 newtons is a kilogram. And again, force of gravity between objects depends on the size of the object and also the distance from the center of the planet. We'll talk about that. right, so if we just look at some pretty simple examples here. If we're thinking about planets, if we have the Earth versus the moon. Have you guys seen old video clips that they took of men walking on the moon? Okay. So the moon is obviously much smaller in terms of mass than the Earth. Where is there a greater force of gravity? Where's gravity greater? Eli? No. The Earth. Force of gravity is greater on the Earth. So where would one, if we have that block of metal I had, where would its, how would its weight on Earth compare to its weight on the moon? Herschel?
It would be heavier on the Earth than the moon.
Yeah. Its weight on Earth would be higher than its weight on the moon. How would its mass compare? Courtney? Yeah, they're equal. Mass doesn't change just because you brought this metal cube to the moon. Its mass is the same. If we compare Jupiter to the Earth, Jupiter, a much larger planet. Joey, how is the force of gravity compared?
Earth has greater gravity.
Not than Jupiter. Jupiter is much larger. Has a greater mass.
I thought Jupiter was like a gas.
It is, but it still has a greater mass. Therefore, it has greater amount of gravity. So this object's weight would be what on Jupiter? Emma?
They would be less than, or greater than.
The weight on Jupiter would be greater than the weight on the Earth. How about mass? Equal. Okay, if you think about on the Earth, if you're going to measure your weight on a mountaintop versus in a deep valley, gravity on the mountaintop would be what? Nicole? Would be less than the gravity deep in the valley. So your weight on the top of a mountain would be, Nicholas? Less than your weight deep in the valley. So in summary, your mass doesn't change with location, but your weight can. Weight is dependent on the force of gravity, and that varies from place to place. If we think about the moon itself, the moon's about 1/6 as massive as the Earth. So the force of gravity on the moon is about 1/6 of what it is on Earth. So when you look at video, and I'll show you some clips in a minute of people walking on the moon or jumping or doing whatever, how do they move? Courtney?
Very, I don't know, they kind of go on the ground, but once they go on the ground, they just bounce right up.
Yeah, they stay airborne much longer. Okay, they can jump and stay higher in the air for long or take longer strides because the force of gravity pulling down on them is 1/6 of what it is on Earth. Okay? Gravity on Earth is about, the force we ascribe to it on average is 9.8 meters per second squared. Force of gravity on Earth. On the moon it's about 1.64 meters per second squared. So much less. And again, we can find the weight by multiplying the mass of the object times force of gravity. So your mass on Earth, if we're 70 kilograms, we multiply that by the force of gravity is about 687 newtons. On the moon, the mass doesn't change, but the force of gravity does. The weight would be about 115 newtons. So mass doesn't change with location, but weight can. That's the key thing to understand. 10 newtons is, so 10 newtons of force is 1 kilogram. 1 kilogram is 2.2 pounds. So 10 newtons would be 2.2 pounds. So 100 newtons would be 22. All right. Any questions about mass versus weight?